Going live. All right, 4, 8, 19. Okay, so I think a lot of these, I'll probably do on a separate sheet of paper. Okay. Number one, I've got e to the x equals 10. Okay. So what we need is on the side here, a little side work here. We have a base to an exponent equals an answer. That's exponential form. Then what you can do is rewrite that as log of your base of your answer equals your exponent. Okay, so that's going from exponential form to log form. Okay, and that's on the board in green over there. Okay, but anyway, it doesn't hurt to have it in our notes, right? So that's what I'm going to do is transpose it from exponential form to log form. So I'm going to rewrite this as log base e of 10 equals x. Now I'm not asking you to solve it. I just want you to rewrite it. Now the one thing I will do is log base e is just natural log. I would like to see that. Okay, you see log base e is just ln of 10 equals x, and that's what I'd like to see tomorrow. Okay. Okay, thumbs up.
Yes.
Okay, number 2. You guys, oh yeah, it's coming back to you, isn't it? Okay. Number 2 says rewrite it in exponential form. So I go log base 8 of 16 equals x. So I'm just going to take it from my log form to my exponential form. So all right, here's my base, 8. I'm going to go 8 to the x equals 16. And that's all we want. Don't solve it. Don't solve it. Done. So make sure you can transpose it from one form to another form, okay? Don't solve it, just rewrite it, okay?
I thought that answer goes on the outside.
Yeah, there it is. There's your answer. There's my base. That's my exponent. It doesn't look like an exponent, but that's my exponent. Because logarithms are exponents. I think I've said that before, haven't I? Logarithms are exponents. I don't think they look like exponents, do they? But they really are exponents. Okay, 3. Rewrite this expression as a single logarithm. Okay, so I've got my... Oh, I better do 3 down here. It's too long. Slide this up. So I've got log base 4, whoops, of 16 plus log base 4 of 10 minus log base 4 of 20. Okay, so logarithms are exponents. So we're going to treat them as exponents. So if we add bases, we multiply their exponents. If we subtract exponents, we're dividing their bases. So I'm going to rewrite this as log base 4 of all of this. Well, it's going to be a 16 times a 10 divided by 20. Okay, here's my times becomes, my plus becomes a times, my subtract becomes a divide. Okay, and I can simplify that. That's what, let's see, 16 divided by 20, is that 88, right? Log base 4 of 8. Okay. And that's just 160 divided by 20. Okay, yeah, Daisy. That's okay, it's Monday after spring break. I know. Good thing it's not a test, just review today, right? Nothing new today, that's good, right? Just stuff we have to remember. Okay, number 4. I'm going to graph this. Let me get some graph paper out to make it look nice. Okay? Okay, number 4. I'm going to graph y equals log base 2 of x. Okay, so the easiest way to graph log base 2 of x is to actually graph its exponential, okay, and then reverse it. So what I would do is graph first, because you're going to have to do both, y equals 2 to the x. Okay, I'm going to graph that first. I'll graph y equals 2 to the x first. That is its inverse. So logarithms are the inverses of exponentials, okay? So I rewrote this as y equals 2 to the x, which is the inverse of this log base 2 of x. Okay, so the reason I like to do that is because you'll see it makes it easy to graph the log. All right, we can do a little bit in our. Can we do a little bit of graphing in our head because we're smart? Sure, we can. All right, so let me put this in. What color do I want to use? How about How about purple? I'll put this one in purple, huh? So, you ready? Let's do this in our head, okay? So if x is 0, 2 to the 0 power is 1, okay? Okay? If x is 1, 2 to the 1 power is 2, right? If x is 3, that's 2 times 2 times 2, which is 8. 1, 2, 3, 4, 5, 6, 7, 8, okay? If x is negative 1, if x is negative, then 1, then we get a 1/2 because 2 over 1. If x is negative 2, we get 1/4, and so on. Okay, so what we get is a graph, our exponential, that looks like this. Okay, now to get the log, we're just going to reverse it, because the logarithm is going to be the inverse of it. So let's go back and do the log in green. I'm going to do it in green. Okay, so how do you do the log? Well, all right, so this point right here, let's do its inverse. This point is at the point 0, 1. The opposite would be at 1, 0. Capiche? This point here is at 1, 2. This point's at 1, 2. Its inverse is at 2, 1. This point, which I didn't draw very well, is at 2, 8. Its inverse is at 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 2. Okay? This point, which is at negative 1, 1/2, would be at 1/2, negative 1. This point, which is at negative 2, 1/4, would be 1/4, negative 2, and so we get the log graph looks like this. They are reflections of each other over this line because they are inverses. Remember that line right there? We have a horizontal asymptote right here. Hopefully it's all like, hopefully it's, you're remembering this maybe. We have a horizontal asymptote to give us a boundary for the exponential, and we have a vertical asymptote right here to give us a boundary for the log. I know. Monday after spring break. Sorry, guys. Thumbs up. All right. All right. Number 5. The graph g of x is translate. Okay, so this is going to be helpful because if you take a look, let's take a look at 5. All right. Let's take a look at 5. Okay, now, what we just did, I want you to look at these carefully, okay? What we just did was, this green's a log graph, right? So what happened? See the green graph? What happened here? What happened? If it got reflected over what? X or Y? Okay, so it flips over the X, that means all the Y values are negative, right? So this graph is probably going to be f or g of x equals a negative log of x. Does the negative make sense? I mean, take a look at the green graph. That's the original log, right? And look at this graph. Doesn't it look like it's upside down? Which makes it a negative log of x. A lot on a Monday morning after spring break, huh? Yeah. Okay. And go along with that for number 5. 6. So 5 would have been g of x equals negative log of x. Okay. All right, 6. Here comes the easy stuff. Seriously. Honest, here comes the easy stuff. Are you ready? Number 6. Easy squeezy. 6. Do you have a calculator? It's going to be easy. I have 10 to the x equals 11,345. All right. So we learned logarithms specifically for this step right here. How do we get this out of the exponent? We take the log of it, right? So let's go straight to the log base 10 of 11,345. Now the cool part is log base 10 is right here in your calculator, right? Log base 10 is this log here. See log base 10 right there? So I'm just going to simply go, okay, I can do this. I can go log after I turn it on. And I quit all that stuff. I'm going to go log of 11,345. About 4.05. Easy. Thanks, Kylie. Let's go. Yeah, this is easy. Heck yeah. 4.05. Okay, then how about number 7? Oh, 7. I can't. I'm not going to be able to do. What's wrong? A negative, because I'm going to go log base e of negative 8 equals x. Like, can't be done, right? Didn't trick me. No solution. You could try it, but I bet you're going to get a weird answer on your calculator. Domain error, right? Yeah, it's definitely domain error. Okay. How about 8? Does this seem easy so far? Got log base 3 of x equals 5. Okay, so let's change it. Let's change it to exponential form. Let's go 3 to the 5. Let's go 3 to the 5. So we're just going to go straight to 3 to the 5 equals x. What is 3 to the 5th? I don't know. Calculator's made for, right? 3 to the 5th power. How about 243? How am I doing?
All right.
I like to hear that. All right, logs aren't hard. 9. We can whip this paper away. Okay, number 9. Let's do number 9. Number 9. Number 9's easy too. You just have to divide by 6 first. Okay, I want to make a point here. I'm going to do my Mr. Davies crazy stuff, okay? Do not multiply these. Don't do it. Do not pass go. Go straight to jail. Do not collect $200. Don't multiply 6 times 3. Divide by, no it's not. Divide by 6 first, okay? 72 divided by 6 is 12, right? Now what?
I guess you call it good.
Let's change it to a log. Let's change to a log. Because the whole reason we do logs is to take care of the exponents, right? So we're going to go log base 3 of 12 equals x. I think we got a log base in our calculator, don't we? Remember that? So if we go to our catalog, no, go to math, right? Go to math. Go to math. Go way down. Log base, right? There it is. Found my log base. You guys see that? Found my log base. Enter log base 3 of 12. I get about 2.26.
Wait. I did it wrong.
It's okay. What do you think? Not too bad? Just don't multiply 6 times 3.
18 to the third power equals 12.
Yeah. So then, 10.
3x.
5 to the 3x minus 9 equals 125. Okay, there's 2 ways to do this. 2 ways. One, you could change it to log base 5 of 125. You could. You could go straight to, and I'll show you. You could go log base 5 of 125 equals 3x minus 9. You can do that, okay? You'd need a calculator, log base, or I recognize, for me personally, I would rather do it this way. 125 is the same thing as 5 to the third power. It's faster and it's easier if you can see this. 125 can be a base 5. And then if you got the same base, you can just solve for x and go 3x minus 9 equals 3. That's easier. The other way will work. This way will work, but it's kind of tedious. If I'm smart, I can do it this way. Then plus 9, 3x equals 12. Divide by 3. X is 4. Right? Kathy's going, yeah, I got this, Mr. Davies. Okay. Yes? Okay, I'll wait and I'll turn my page in a second as soon as you get this, okay? Logs are not hard. They sound hard, don't they? Logarithms. The hard stuff are those F words. Seriously, functions, fractions, factoring. All right, number 11. 11 is like a warm-up. Log base 4 of 4x minus 5 equals 2. Okay, so let's change it to exponential form. 4 to the 2. 4 to the 2. So we're going to go 4 to the 2 equals 4x minus 5. Okay, how am I doing?
Sure.
And that's easy. 4 to the 2 is 16. Right? plus 5 plus 5. 21 equals 4x. Divide by 4. What's that? 5 1/4. I think so.
Sure.
I think so. Somebody can do fractions in this room. There's somebody, one person in this room that can do fractions. Jeremy, definitely. 12. You guys ready for 12? Ln of 2x plus 9 equals ln of 5x minus 6. Okay, so ln of this equals ln of this, right? Technically, I could take them both to the e power, but really, you can just almost cancel and say, well, what's inside of here has to be inside equal to this. Does that make sense? I can prove it to you. I can show it to you, but does it make sense if you've got ln of this equals ln of this? So what we really want to say is this 2x plus 9 must be equal to 5x minus 6. And if you want me to prove it, to get it to this step, I can.
Please.
All right, we'll take them both to the e power. Take them both to exponential form, you'll get it. All right, so minus 2x minus 2x, 9 equals 3x minus 6, right? Plus 6, 15 equals 3x. Divide by 3. I get 5. Is 5 okay? Yeah, 5's okay. 5's not going to give me a negative answer, right? 5 is okay. If I plug 5 in, I'm still going to be good. I'm going to be golden. Hey, we're almost done, right? We're almost done. Okay, okay, number 13. 13. I've got ln of x equals 0.8. Okay, what do you think? What do you think?
Add 5.
There's an invisible number, e. Okay, there's an invisible number, e. Okay, right? There's an invisible number, e. And what can we do with that e? What are we going to do? E exponential. E to the 0.8 equals x. Use my calculator to get that value. I'm going to go e to the power of 0.8, about 2.23. About 2.23. How's that? Am I doing okay? Turn the page. Okay. Make a scatter plot. I can do that. Got a piece of graph paper here somewhere. Make a scatter plot. All right. And I want to do a nice job, so I'm going to use my ruler. Okay. Okay, so years go on my x-axis. Sales go up here, sales and years. I've got 1, 2, 3, 5, 6. Right, and then I'm gonna go probably by tens. 10. Yeah, how's that? There you go. Thank you. Thanks all. 10. 20, 30, 40, 50, 60, 70, 80, 90, 100. Thanks, Saul. How's that? Better? So scatter plot. 1 and about 12, about there. 2 and 16, about there. 3 and 25, about there. 4 and 36, about there. 5 and 50, yeah, right about there. 6 and 67, and 7 and 96. Definitely looks exponential, doesn't it? Definitely looks exponential. Exponential. Pretty sure that looks exponential, okay? So we've made our scatter plot. So then find an equation. Well, I'm going to use the calculator. And I'm going to use the stat button, okay? So we're going to go into stat. Okay, we're going to go into stat. Okay. And I'm going to find the exponential regression So we're going to go into clear. I'm going to go into stat. I'm going to go to edit, list 1, list 2, clear off the list, clear off that list, and then I'm going to start putting in my numbers from my data numbers in. So I'm just going to start putting these numbers in. I'm going to go 1, 2, 3, 4, 5, 6, 7, right? And I'm going to go 12, 16, 25, 36, 50, 67, 96, okay? Am I going too fast? Maybe.
Oh,
Stat. We're going to do some statistics, okay? Gavin, tell me when you're ready.
Yeah, I'll do that.
Okay, so after that, I'm going to go to calculate, right? And the one I want to find is the exponential. So it's in here. We just have to find it. There it is. It's number 10. Exponential, right? Exponential regression line. Enter. Calculate, right? Go down to calculate. And I get an answer. Okay, and I even get an R value. It's not a bad R value. So I have a y equals an 8.46 times a 1.42 to the x power. Okay, there's my equation. Okay.
Wait, which quad thing?
Not quad, no, exponential. Go all the way down to 10. It makes sense, right? Exponential regression line.
That makes sense.
It does. Gavin, did you get the same thing I got? Hopefully.
Yeah.
Okay, good. So there's my equation, right? That's not too bad. We can do that. The calculator can do that for me, right? Now, let's use our equation. So it says, okay, year 10. So year 10, let's just plug 10 into my equation, right? So let's go y equals 8.46 times 1.42 to the 10 power. We'll let the calculator do the work, right? Okay, so I'm just going to clear that. 8.46 times a 1.42 to the power of 10, and my sales projection is about 282 trampolines. Is that in terms of thousands? No. So then, finally, almost done. How many years will it take to sell 500? Okay, so now 500. Now to do some math, I can handle this. So we take our equation. So if I need 500 question mark, how many years? How many years? Okay, and I'll slow down so you can watch. So in this case, we're going to use our equation. Y equals our 8.46 times my 1.42 to the x power, right? So I want to solve for x. So now in this case, the 500 is the y value because that's going to be the number of trampolines, and x is the years, okay? All right, what do we do? Let's solve for x. What do we do? Don't multiply those, please. Don't multiply those.
I divide.
Guys agree? Divide? Yeah, thank you. Divide. Divide first. Okay, so what is 500 divided by 8.46? I get a 59.1 approximately. 59.1 equals a 1.42 to the x power. Okay, now how am I going to take care of that x up here? What am I going to do?
Log.
Okay, we're going to take a log of it. So I'm going to go log of base 1.42 of my 59.1 equals x. And my calculator can do that. Even though there's decimals, I've got that log base thing, so I'm going to go back into my math. I'll go all the way down to my log base, right? Here it is, log base of 1.42 of the 59.1 And my calculus should do it for me. About 11.63 years. Or 11.6, about 11.6 years. Okay, what do you think?